Today, at the South Washington County Library, we have found a test subject to perform our acceleration elevator project.
Hello! Today we are at the South Washington County Library, and my name is Minjin Ju, and my fellow goody-goody partner, Susan Shaw.
Alright, today we're going to be testing acceleration when we go up and down an elevator. For our test subject, we found this man who weighs about 130 pounds. We're going to be using his weight to see how much his weight fluctuates during acceleration and deceleration.
The theory behind our project is Newton's second law. The acceleration of an object is directly proportional to the net force and is inversely proportional to the mass. In other words, if the force is doubled, the acceleration is doubled, and if the mass is doubled, the acceleration is half.
Before we began our experiment, we created a hypothesis, and our hypothesis for this project was when the acceleration is positive or when the elevator is going up, the weight on the scale should have an initial increase, and when the acceleration is negative or when the elevator is traveling down, there should be a temporary decrease in weight.
We're going to be going down, down, down the elevator.
The subject weighs around 130. Now we're going to be going from level 2 to level 1. Notice there was a 5-pound decrease when the elevator went down.
Passengers, fasten your seatbelts as we are right now going up.
Alright, we're going to be going up, up, up the elevator right now.
Alright, so right now the subject weighs about 130 pounds. We're going to be going from level 1 to level 2. Notice this time that the weight went up 5 pounds instead of down 5 pounds.
Now we calculate.
For our project, we had a test subject who weighed roughly 130 pounds. In order to calculate everything, we needed to convert pounds to kilograms. For converting, we knew that 1 kilogram is roughly 2.20462 pounds. In order to convert the 130 pounds to kilograms, we needed to divide 130 pounds by 2.205, which is equal to about 58.967 kilograms, which we rounded to a 58.97 kilograms. Now we're able to start calculating. In this experiment, there were two main forces that are impacting and significant to this project. We've got the force of gravity, or Fg, and Fn, which is the normal force. The force of gravity is the force that gravity is pulling down on the test subject. And we have the normal force, which is the force that is pushing up on the subject. This number is also indicated on the scale. To find force of gravity, we need to take gravity and multiply it by, which is 9.8, and multiply it by our subject's weight, which was 58.967 kilograms. This is equal to 577.91 newtons. We will be using this number for further calculations. So in this case, the normal force, or the normal weight, was 56.70. Now to find normal force, we take the 56.70 kilograms multiplied by the force of gravity. Now this yielded 555.66 newtons. Now to find force of gravity, we had to multiply the normal weight, which was 58.97 kilograms, which is the weight when there was a zero net force on our subject, multiplied by gravity, which was 9.8, and this yielded 577.91 newtons. Now, when we subtract 555.66 by 577.91, we get a negative 225.25 newtons as an answer. Next, we know that the equation for net force is also equal to mass times acceleration. When we isolate acceleration, we get that acceleration is equal to the net force divided by mass. Using our data, we get negative 22.25 newtons divided by 58.97 kilograms, which is equal to an acceleration of negative 0.377. This confirmed our negative acceleration. Although theoretically acceleration should have been the same going up and down the elevator, as there is a set speed that the elevator should be going at, we still wanted to see if our data confirmed this. So theoretically, we should have had the same acceleration when the subject went down, but let's prove this in our calculations. Again, we will be using one of the net force equations, in that the net force is equal to normal force minus the force of gravity. The greatest weight the subject reached was 61.24 kilograms. Now we need to find normal force, which is 9.8 times 61.24 kilograms, which gave us 600.125 newtons. Now to find normal force, the force of gravity, which was equal to the same force of gravity when the elevator was going down, which also equaled 577.91 newtons. Now to find the net force, we have to subtract our normal force of 600.152 minus the force of gravity, which is 577.91 newtons, giving us a positive 22.246 newtons. Now, because again, we know that the net force equation is equal to mass times acceleration, we're going to isolate acceleration again and get net force divided by mass is equal to acceleration. So in this case, we have 22.246 newtons divided by the mass of 58.97 kilograms, which gives us a positive acceleration of 0.377 meters per second squared.
Finally, just going over hypothesis, we see that we predicted correctly. Our results did indeed show that with a positive acceleration, the weight increased, and for the negative acceleration, the weight decreased. You may be asking why the weight went back to normal when the elevator was moving at a constant speed. Well, this is because when the elevator is moving at a constant speed, the net force is zero. Therefore, because there are no forces impacting the weight, the subject's weight should return normal and remain the same. So there you have it. Hope you learned something today.